In this lesson, we're going to discuss the distributive property. So when we're talking about the distributive property can be done over addition, or it can be done over subtraction. So algebraically, what the distributive property says is that anytime we have a factor, I'm going to call it A, times an expression with two or more terms, that factor has to be multiplied by each of the terms in that expression. So we get something that looks like this as a result. If the expression has subtraction in it, like here, then the only difference is that when we go ahead and we distribute, we would put a subtraction sign in between the two resulting terms. So let's look at an example. Okay, so here we have the expression 5 times the sum of x plus 2. So I can go ahead and I can look at this like a model, an area model specifically. So the factor that I'm multiplying the expression by, x plus 2, I have to multiply the 5 times x, and I have to multiply the 5 times the positive 2, and 5 times 2 is 10. Since I don't know what the value of x is, I can only write it as 5 being the coefficient of the variable x. So the question is, are these two expressions equivalent? Let's figure it out. So let's say that x is equal to 3. So if in the original expression, 5 times x plus 2, we evaluated with 3, we would get this. 3 plus 2 is 5, which means it's worth 25. Well, in our distributed expression, we got 5 times x plus 10, and I forgot to write that over here. And so if we go ahead and replace the x with our 3, 5 times 3 is 15, and 15 plus 10 is 25, which is the same thing that we had gotten in the undistributed expression. So the two expressions are equivalent to each other. So let's practice using the distributive property. Okay, so on your own, try and do them. So you can pause the video, or you can do them with me. Okay, so let's see what we got. So if I was going to be going ahead and doing this one here, okay, I'm doing two terms I'm distributing to. I have my factor 2, my terms 3x plus 4y is my setup. And now I'm going to do 2 times 3x in this first box. So 2 times 3x, which gives me 6x. And then I have 2 times 4y in this box, which gives me 8y. So my distributed value is 6x plus 8y. Now, do I have to use the box every time? No. If you want, you don't have to use it. Another thing that I see some students do, which a lot of teachers do as well, is they just kind of use some lines to help students remember how to distribute. So if the factor you're distributing is on the left, then you distribute to the right. What is 5 times j? 5 times j is 5j. This one's a subtraction one, so it would be a minus 5 times 3k. Well, 5 times 3 is 15. And since we don't know what the value of k is, we just write k as a neighbor. Now, in the bottom two, we see that we have 3 terms to distribute to. So if there's 3 terms to distribute to, we have to make sure that we distribute to all 3 terms. So I'm going to use the box on this one. So what am I distributing? I'm distributing a 7. And I'm distributing it to 4a plus 2b minus 6c. So in the first box we have 7 times 4a. And remember, this is based on an area model. 7 times positive 2b, which gives me positive 14b. That's a positive, so it's a plus. And 7 times, technically it's a negative 6c, but we'll go ahead and call it minus. So I'm going to put the minus sign, 42, or I'm sorry. So I'm going to put the minus sign, and then I'm going to put the 7 times 6c, which makes negative 42c. So what do I have all together? I have 28a plus 14b minus 42c. Okay, now let's try the next one without the box. Now, you notice anything different about this next one? Well, there's a variable in what we're distributing. Isn't that going to be okay? And so if there is a variable in what we're distributing, that just means that it's a factor in what we're multiplying. So when we're going ahead and we're doing it, we just got to remember it means multiply. And so this means 3b times 2a. And so next we're going to do minus 3b times 3c. And next we're going to do plus 3b times 5k. So now when we're simplifying, this right here means 3 times b times 2 times a. And remember, it doesn't matter what order you multiply numbers in. That's the commutative property. So 3 times 2, we know what that is from elementary school. That's 6. But b and a, we don't know the values of them right now. So the only thing we can do is write them as neighbors. So we would write it 6 times a times b. So the next one, keep our minus sign. Do we know what 3 times b is? No, but we know what 3 times 3 is, 9. So b and c, we just write them as neighbors. Plus sign. We don't know what b is, we don't know what k is, but we know that 3 times 5 is 15, so we write b, k. And there is our expression. Now, just like we can distribute, we can undistribute. That's called factoring. So factoring means to take out the common factor of the 2 terms. So remember, we've talked before about common factors. What's the least, what's the greatest common factor? Well, here's where it comes into play. And this keeps getting used and used again and again in math. So when we're looking over here at the term 3x and 12 in this expression, I'm thinking about the numbers 3 and 12. What is their GCF? Well, the biggest number that divides 3 and 12 is 3. And so that's what I'm going to undistribute from them. So 3x plus 12. Okay, if I wanted to go ahead and I wanted to use a box, I would think about 3x plus 12. And I want to take out a 3. So I would think, okay, if I have 3x and I divide it by that 3, what would I get? I would get x. If I had 12 and I divide it by that 3, what would I get? 12 divided by 3 is 4. So that means 3x plus 12 in factor form would be the 3 times what was left over, x plus 4. Okay, let's try that on some others. So 5x minus 15y. So what's the common factor, or the GCF, of 5 and 15? Well, 5 and 15 are both divisible by 5. So that means that I'm going to take out a 5. Now, if I don't want to use the box, okay, I'm going to go ahead and keep my minus sign in the middle. And I'm going to think, okay, if I divide 5 times x divided by 5, what do I get? Well, 5 divided by 5 makes 1, or 1x. If I take 15y and divide it by 5, and I would be doing this in my head, 15 divided by 5 makes 3, and I can't forget my y. So my factored form would be 5 times the difference of x and 3y. Okay, on the next one, I have 8 times jk, or times j times k, plus 20 times j times p. So not only do they have a common factor in the coefficients, but they also have a common factor in terms of the variable. So what number divides 8 and 20? That's the greatest value. So the GCF of 8 and 20 would be 4. And we see they also have a j in common. So the GCF of these terms isn't just a 4. The GCF is actually going to be 4j. So if we're thinking about 8jk, and we need to factor out 4j, 8 divided by 4 will give us 2. And then j divided by j will leave us just a k. So let's see what we have. So we have our common factor is 4j, leaving us 2 times k in the first term, plus, and then in our second term, we're going to go ahead and factor out 4j, (20) divided by 4 would give us 5, and j cancels j, leaving us p. So the factored form, or the undistributed form, would be 4 times j times the sum of 2 times k plus 5 times p. Okay, and here's our third one. So we have 14 times a plus 35 times b plus 21 times c. Now, do they have anything in common in terms of the variable? No. So what's the GCF of 14, 35, and 21? They're all multiples of 7. So 7 times what number makes 14? 2. Minus sign. 7 times what number makes 35? 5. 7 times what number makes 21? 3. And not forgetting my variables, I get that. The factored form is the product of 7 and 2 times a minus 5 times b plus 3 times c. And that is how we're going to be using the distributive property in the future of math.